Hello and welcome to Vape. This is Jordan Flady, and I've been promising a lot of people for quite a while that I would do a build video. There's a lot of technical stuff we can get into with builds about heat production characteristics, and then all kinds of complicated stuff with the Tiger fuse, twisted, nipple clamp, Clapton staple, whatever, that kind of craziness. But this build is very simple. I use it exclusively on all my devices, really, so I use it exclusively. It's the only build I really do. I can do the other stuff. I've done a ton of the other stuff, but this one produces absolutely phenomenal flavor, pretty solid clouds, and is a tremendous battery saver. It runs around 63 to 83 watts, has a comfortable, warm, moist hit, and I'll get into showing you that here in just a second. This is the Vape Drag. It is a fairly popular, relatively new device. It's a very solid metal frame. I'm using this today because this is our demo box. And up in top here we have the Phenotype L RDA. It has awesome airflow and a pretty solid two-post build deck. I'm going to put this back together. The drip tip for it is phenomenal and it hits like a champ. That said, let's get into this. The build that I want to do today is 6 wraps of 22 on a 2.5 millimeter bit. It's smaller than the typical diameter, but this is what we use as Kanthal, 22 gauge Kanthal. This is just the small strip I'm using to show you. I have pre-staged the build, not completed, but pre-installed just to save some time so I don't have to fidget with it off camera. The tools that you need to do builds typically a pair of nice tweezers. You can use regular tweezers, you don't have to use anything fancy like those dental kind of tweezers or anything like that. Old Faithful pair of needle nose pliers for squeezing your build later on. Some diagonal cutters to trim excess Kanthal. A pair of scissors to cut your cotton, and one of the most important parts I find is your cotton itself. This is Japanese cotton. It has a consistent grain and thickness, which is really important when wicking your coils. The consistent thickness means that you're not going to have ultra dense spots and more sparse spots, so you'll have pretty consistent amounts of wicking throughout your coil. You won't end up with hot spots and scorching of your juice unless you don't prepare your coil properly in the first place. We'll get into all that. Oh, and by the way, our 2.5 millimeter bit. This goes onto our handle right here, and we have our top twister part right here. So what I'm going to do is I'm going to show you how I start my coils and just the ideas of wrapping. So when you're putting your coils together, you want to consider the diameter of your, the inner diameter of your coil, which in this case is a 2.5 millimeter bit, and the length of it. If you have coils that are too long, too many turns and things like that, you'll end up with a situation where the center of your coil will starve for juice before the outside does. So right now I'm starting by giving it a half turn facing myself. I do this so that 1, it's easier to count the number of wraps, but 2, I have an even starting and ending point. Since I'm doing this, this ends up actually being a 7 wrap build, but it's 6 whole wraps and 2 half wraps. The half wraps come on either end of the coil. So I start out with my half turn, and then, pardon the limited space here, I'm going to give this just a few turns here to show you what I'm talking about, and then I'm going to bring it up close so you can actually see it. And then I'm going to get it to zoom. Right, so this is only 3 wraps right here, but you'll see how it is. That's just doing those couple turns right there is enough to get it started. You want to keep your coils fairly tight. You don't, if you have one of these tools, you don't actually have to press to get it to do it. You can just naturally glide it. But you can also do this by hand with a screwdriver, which I'll show you here in just a second with my other scrap of wire. When you're doing these kind of twists and stuff on here, if you keep it, when you're doing it by hand, you have to press a little bit to get it to even out. But you'll notice that that tool, when doing it by hand, that tool makes it much tighter than the hand turns. So that's our 6 turns right there. But that's obviously not long enough to actually install into anything. So this won't be anything other than just a scrap demo piece. Now, doing it totally by hand, I grabbed our screwdriver that I showed you just a couple seconds ago, setting down my other tools, and here's our scrap of wire from this. So you're going to hold your screwdriver and your piece of wire in one hand, and you will start off with your twist, and then you'll just give it your go like you did before in the other one I showed you just a second ago. And make sure you don't have any overlap, but at the same time you don't want there to be any real gaps. I'm not going to keep doing this in here because I literally have a foot of space between the posts of what's holding my camera up, and this looks like shit, so it's not going to do you any good to see me do a shitty build on here. That said, once you have done that on our RDA that we're working with here, the Phenotype L, you'll install them simultaneously into the posts. That's my only complaint about the Phenotype, is that you have to install the coils simultaneously. But that'll work for our purposes here. It's very easy. It's what I use personally, but it's not big enough of a downside for me not to bother using it. I really like the piece. So I'm going to pull this apart, put it back onto our deck right here, and I'll show you what to do once the coil is physically installed. So I'm screwing back down the pre-prepared piece that I put together just a couple seconds ago, because the first time I recorded this, it actually took me 5 minutes to get everything together. That was mainly because I was doing it within the screen here, and that recording nobody's going to see. So great. So once you have your coils installed, you will have excess pieces of wire floating out around your post holes right there. So you'll use your diagonal cutters to trim off the extras, snip, snip, you know, like that, flush cut up against the side of the posts so that you don't snag your cotton when you pull it through later. And now you'll notice these look all kinds of jagged and twisted, and that's not what we're going to do. When you're building your coils, you want to have them vertically centered. With respect to each other, they will be both about the same distance from the center posts, as well as the same height from the deck, and they will be perfectly able to be seen through. So with that piece we were working with earlier, that bit that I used to turn the coils on, I'm going to insert that through one of the coils and make it parallel with the deck. I'm talking physically parallel. It's already electrically parallel with the other coil. And I'm going to do the same thing on the other side. This is just the first step in preparing it. So when you have flipped them so that they are parallel with the deck, this could use a little bit more work. You got to make sure that they are even with each other and they look totally symmetrical, almost totally symmetrical. It's hard to do under a camera. I've never done this before under a camera. Doing a little work here just to even these out, and then we'll go through with the next parts of the process of actually preparing the coil. Now these are pretty close. It shouldn't really make too much of an impact on our heat up rate. The point about making sure that they're even distances and even heights and even characteristics like that is so that when you hit them, they hit and they fire at the same time, they heat up at the same rate, and you don't run into any crazy issues. So here on our Vupu, oh, of course this is a new coil, yeah, absolutely, yep, 0.15 ohms. This build usually comes out between 0.15 and 0.18, give or take. Mine, it really mainly depends on the box and how far away from the center post they are. So we're going to start pulsing it up, and if you notice here, the legs are heating up before the rest of the coil. This is set to 80 watts. It's toward the higher end of my power range that I prefer for this coil. So you'll notice the coil is not heating up evenly at all. You want them to heat up from the center of the coil outward. So what you're going to do is once you have started to warm it up like that, you're going to give them a gentle squeeze. I squeeze on the whole wrap sections, not the half wrap sections, because the half wraps are mainly just for controlling the positioning, the physical positioning, giving it a little extra space to work with. So you'll pinch them both about the same and start to pulse them up again. And you can already tell that those are heating up a lot better than they were before. Now I notice here on the back side of some of these that they're not evenly, perfectly lined up with each other. So I'm going to pinch the back sides a little bit too, just to make sure that heat comes out even. And we're going to start pulsing it up again. Oh, look at that. Perfect. They ramp up at the same rate and they heat up from the center outward. I'm going to blow this down to cool. I'm going to blow on it just to cool it down a little bit. And then I'm going to show you that they both heat up at the same time, and then we'll be good to go with our wicking step. Cool. Okay. So let's see them heat up. Okay. They heat up at almost perfectly the same rate. The one on the right is heating up slightly faster. Let me see if I can replicate that. I'm going to cool it down again, try one more time. All right, let's pulse it up. Yeah, the one on the right's heating up faster. All right, so when you have things like that, first thing you want to do is check your post tightness. I'm going to pull it off camera here because I don't have enough vertical height to work with, and I have twisted my screws a little tighter. Let's see if that fixes it. Hey, looks like it almost got it. Cool. Cool it down, try it again. And the one on the right still heats up a little faster. Let's pinch the one on the left a little bit, see if we can control that spacing a little bit. If you pinch your coils while they're cooling down and blow on them gently to cool them down farther, you kind of harden the metal into the position you want it to be in. So I have pinched the one on the left, I've blown on it. Let's try to bring it up again. No, that slowed it way down. I also extracted a lot more heat from the one on the left from the position that it was in because I'm pinching it with metal tweezers. So I'm going to blow them, cool them both down. Try to bring them back up. Nah, the one on the right's still being funny. This time I'm going to cool down the one on the right, pinch it together, cool it down, and go from there. Okay. Cooled them both down again. Let's bring them back up. Hey, there we go. Now they're even. Great. I'll let you watch that cool down for a second. Next thing you want to do is you want to grab your Japanese cotton. And I'm going to move the box out of the way and show you. When you are wicking your cotton into your coils, wicking is almost as important as the build itself. If you put too much cotton in the center of your coil and underneath your coil, you're going to starve the center of your coil for juice. If it's too thick, too dense in there, the liquid that is very thick because it's a VG-based juice, it's not going to wick in there very well. The reason I have the bit out here is because whenever I cut my cotton to be almost the same diameter, only ever so slightly larger than the bit that I use to make the coil with. The reason I do that is because you leave enough space in there. You don't end up putting too much cotton, but if you put too little cotton, you'll get dry spots on your coil, so whatever juice wicks on there will immediately scorch, and it'll start to taste burnt and dirty and nasty. So I'm going to snip off my Japanese cotton to about 2.5 millimeter strips. I'm going to use 2 strips just because it makes it easier for this video. And I'm going to clip these off here as we described, cutting it down to about a 2.5 millimeter strip. Strip number 1. Ding. And then strip number 2. Ding. Right there. So we will take our strips, and you hold one end of it in one hand and roll it gently between your fingertips. What you're doing here when you're rolling it gently between your fingertips is creating a tight spot on your cotton so that it will fit well through your coil. So you install it, slide it through just a little bit, and you grab your handy dandy tweezers, pinch onto that edge right there, pull it through a little bit, and then you tug your cotton so that it slides through. When you're sliding your cotton around, you should notice that your cotton moves pretty well without actually separating your coil from the posts or anything like that. And then once you've done that, you'll want to leave enough cotton on either side of your coil to ensure that you can just touch the bottom of the deck. Now I'm going to trim off the section that we twisted up with our fingers because I don't want nasty finger in my juice. I'm going to twist the build around, and I'm going to do the same thing on the other side, wicking both coils the same way. This is kind of like threading a really big needle. Also kind of sucks doing it from the position we're doing it right now. All right, tug it back through. It's important to kind of tug it back and forth in the center of your coil because that actually allows it to fluff up in there and fill that space pretty well. So using the template from my previous cuts, I will trim off this one to be the same, roughly. And we're going to take our flat A from earlier, clearing out the junk out of our way here. Tuck the cotton underneath your coil, like so, and like so. And then giving it a good wrap under there, tucking it both. You don't need it to fill the gap beneath it. If you put too much cotton in the bottom, it's not as bad as putting too much in the center, but putting too much cotton in the bottom, if you put a ton of cotton in the bottom of it, juice goes where the cotton's at. So fun fact, if you leave a ton of juice or a ton of cotton in the bottom, you're going to get a ton of juice in the bottom. Next thing we're going to do is we're going to wet our coils. When you start to wet your coils for the first time after installing them, I like to start with the center of the coil just because that provides enough juice to the center of your coil when you start wetting it to actually get it to soak in. And then whenever I start to wet my legs here, you make sure that you have enough on the legs of the coil so that you actually get a good solid moisture soaking into everything. Now once everything looks wet and stays wet, we're going to be ready to fill up the juice well in the center here. So a couple good squirts. What I am vaping right now is a white wine blackberry with pear and a little bit of sweetness to it. So I filled up my juice well, gave it a pulse, and we're going to fire it up. It puts off some pretty solid clouds. So I'm going to change angles for just a second to give you guys a good idea of what it looks like straight on. That's a build running at 80 watts. So I'm going to go back here, put the top cap on, and we'll take a good old rip. So now you get to see my face. Pretty solid clouds, tremendous flavor. It's a very moist build, and if you have any questions, comments, concerns, bitches, gripes, complaints, please let us know in the comments below. Have a good one.